Metro, maritime environment-friendly transport systems. The basic assumption for the Metro project is the necessity to comply with the actual policies for the environmental sustainability regarding pollutant emissions in the maritime sector. These include the Greenhouse Gases Reduction Plan, issued by the International Maritime Organization in 2013 and valid at a global level, the Paris Agreement, that is the first universal global climate change agreement having legal implications, but addressed only to national and regional maritime transportation, and the Fit for 55 policy, published by the European Union in 2021 and aimed at regulating the maritime transports that have at least one port on the route in a state that is part of the European Union. What are the possible solutions to meet these demanding requirements as well as the future ones? Several technologies already on the market or at an high technology readiness level are available, such as hybrid propulsion systems, energy storage, hull air lubrication, and so on. In the past 10 years, also digital technologies had a huge evolution. Words like big data, artificial intelligence, or machine learning can be found nowadays almost everywhere. Digital technologies can also help in optimizing the usage of the existing fleet, design new ships, and optimize the logistic operations. However, the maritime transport sector is characterized by several interconnected elements that interact with each other in ways that can be not apparent. This makes evaluating the emissions of the actual maritime transportation a difficult job, and makes also difficult designing new assets that can significantly impact on them. So, where to start for designing a new sustainable maritime transport system? First of all, we need a proof of concept of the integration of new technologies on board different types of ships, in order to evaluate their impact as a whole in all their operating conditions and planned routes. We also need to ensure that the land infrastructure is capable of providing the required support for the correct operation of the new ships. Therefore, we need to shift towards an integrated design approach that starts from designing the best ship for each specific application and includes in the design process the entire chain in which the ship is used. This is the core of the Metro project approach. Metro was developed within the Interreg Italy-Croatia collaboration program, which includes the Italian and Croatian regions that are faced on the Adriatic Sea and has the purpose of financing projects capable of improving the quality of life and the conditions of all the citizens in the area. In particular, Metro had the aim of improving the environmental sustainability of the maritime transport in the North Adriatic area, focusing on touristic connections. The project had a length of 36 months, from January 1, 2019 to December 31, 2021, and its total budget has been nearly 3 million euros. Following the integrated approach presented before, the project coupled both technological and logistic actions, trying to tackle the problem from all the sides. To achieve the expected results, the project put together a wide partnership with significant expertise. The University of Trieste, with the Department of Engineering Architecture, was the lead partner. Then there were Wärtsilä Italia and Technomont Shipyard as enterprise partners, University of Rijeka with both the faculties of Maritime Studies and Engineering, the Port Network Authority of the Eastern Adriatic Sea, and the Development Agency of the Eastern County. The project has been divided in 5 work packages, each dedicated to a single aspect: project management and coordination, communication activities, and then 3 work packages for technical activities. Work Package 3 was dedicated to the development of new green ships, capable of reducing the environmental impact in respect to the present solutions. A Ropex and a ferry were selected as ship types, and 2 existing routes were considered, a medium one across the Adriatic and a short one between Croatian islands. After the study of the best propulsion systems, the preliminary design for both ships was developed and relevant system integration points were demonstrated. Work Package 4 was dedicated to the landside infrastructure and on the regulatory scenario analysis, to study all the requirements for enabling the correct support of the green vessels. Finally, Work Package 5 studied the logistic aspects, multimodality and eco-innovative services. Navigational, meteorological and oceanographic analyses were performed, passengers' flow and ships' energy consumption and emissions were studied, and a pilot study for monitoring the passengers' flows in the relevant ports was implemented. Furthermore, a new route for the design Ropex ships that takes into account the actual ports and the future infrastructure was studied. To the purpose of the project, the implementation of virtual prototypes was a fundamental activity to verify design choices and the integration of the studied innovative technologies on board the considered vessels. Virtual prototypes may be defined as computer simulations of a physical product that can be presented, analyzed, and tested from concerned product lifecycle aspects such as design and engineering, manufacturing, service, and recycling, as if on a real physical model. A virtual prototype contains all the information of a certain product necessary for its physical construction and its aesthetic and ergonomic evaluation. Virtual prototypes are a natural advancement of conventional 3D CAD models, providing an accurate geometry description, as well as integrated kinematic, dynamic, and physical properties. A fundamental feature of virtual prototypes is their parametric nature, which allows managing possible design changes during the whole project lifecycle. Such flexibility enables both the automatic modification of ship dimensions and structures following designer inputs, and the evaluation of the best solution in terms of systems layout. All these aspects give to virtual prototypes a role of utmost importance within the innovative integrated ship design approach. Construction and testing of virtual prototypes transform the virtual design models in direct design objects. In fact, a virtual prototype is subjected to checks, analysis, and simulations, and comes to coincide in substance with the finished product itself, allowing to extrapolate a high number of outcomes. In addition, a virtual prototype provides a 3D parametric master model that can be accessible through virtual reality, thus enabling a rich visualization of design choices and analysis of physical fit of components and arrangements, to include verification of intersections between hull, systems, and structures. This 3D model can also be used to analyze ship construction, maintenance, and repair activities through visualization and analysis of maintenance envelopes and interferences. Furthermore, the inclusion of avatars enables measurement of potential human-machine interface issues. This capability provides the opportunity to make production-related decisions in early-stage design phases and, if connected with virtual reality, allows the fast proof of concept of new technologies. For both the Ropex and the ferry developed within the Metro project, a virtual prototype was implemented for the use of the software Paramarine. These models are available on the official Metro project site. As for the Ropex vessel, here's a video in which we can see the virtual prototype of the ship, with a detailed focus on the subdivision of the internal spaces and the locations of the cabins aboard. We can see other images from the virtual prototype for the Ropex. On the left, the distribution of the internal spaces and some structural elements are visible in a from-stern-to-bow view of the vessel. On the right, an example of the CAE results that can be drawn from the virtual prototype is shown. Specifically, the longitudinal weight distribution of cabins and ship structures, such as shell plating, bulkheads, girders, and stiffeners, is reported. As for the virtual prototype of the ferry vessel, here's a video in which we can see the different structural elements of the hull. We started from the bottom shell and grid, and we proceeded with modeling the various decks with their structural members. By adding the side shell platings and refining the superstructures, the entire model of the ship was completed. Here are some other examples of paramarine outputs for the ferry vessel, consisting in the visualization of the model with a specific attention to the decks and the longitudinal weight distribution of structures. The images show just a small part of the capabilities of the Paramarine software and of the possible results that may be drawn from a virtual prototype. Other fundamental outputs are related to the propulsion power calculation and to impact and damage stability calculations, which are peculiar features and activities in the ship design process. To discover more about the Metro project, take a look at the official website at the link www.italy-croatia.eu/mitro.